Good day, students. My name is Mr. Moses Obinna. I'm here to present a topic on further mathematics termed progression, sequence, and sum, which is also known as series. Our learning objective in this topic include as follows. At the end of this learning, I am expecting you to identify consecutive numbers, define sequence and its types, solve problems involving progression, which is also known as sequence, on arithmetic progression, and geometric progression, including its sum and series. Introduction of the lesson. The following numbers are said to be consecutively arranged. A 1, 2, 3, 4, 5, etc. B 3, 6, 9, 12, 15, etc. C 12, 9, 3, 0, etc. Observe from the examples above that the difference between any two immediate numbers is constant. Let's take, for example, A above. 1, 2, 3, 4, 5. 2 minus 1 is 1. 3 minus 2 is 1. You can notice that the constant difference is 1. Hence, any arrangement of elements that maintained a constant difference in this pattern is said to be consecutively arranged. You can notice this if you use example B. You can also see it. If you also use example C, you will also see it there. When we talk about consecutive terms, that is what we mean by that. The difference between immediate numbers must be the same. Let's look at progression, which is also known as sequence. Progression is defined as the arrangement of numbers following a regular and a well-defined order. However, there are types of progression which include as follows. The first one, A, arithmetic progression. The second, geometric progression. The third, harmonic progression. And the last one, we have Fibonacci numbers. For the scope of this lesson, we will be considering arithmetic progression, which is also known as sequence, and each sum, which is also known as series. Arithmetic progression. What do we mean by arithmetic progression? It can be simply defined as a sequence in which a constant value is either added or subtracted from a given term to obtain the next one. The constant is called the common difference, and it is denoted as D. Also, the first element of any progression is usually denoted by A. Let's use example to illustrate this concept. Consider the progression 1, 2, 3, 4, 5, 6, etc. The first element in that example is 1. and it is identified as A. And the common difference can be obtained by picking two immediate numbers there. 2 minus 1, which is 1, can be identified as D. You can also pick 4 minus 3. You can also see it as 1. Any consecutive terms taken, the result is the same. The nth term of an AP. The nth term of an AP refers to the term occupying the nth position if the elements are counted from the first term. It is usually denoted by T sub n, and we shall derive the formula as follows. Let the first term be A. Then the second term will be A plus D. The third term will follow as A plus D, which is same thing as A plus 2D. The fourth term is also A plus D, which is same thing as A plus 3Ds when you add the 3Ds. You can also consider the fifth term. You have A plus D, which is same thing as A plus 4D when you add the 4Ds, etc. Observe above that the constant numbers at the end of the expression is decreased by 1 from the term represented. Then, the nth term can be expressed as A plus D plus ... It can also be seen as A plus bracket n minus 1 bracket D. Hence, we can conclude that the formula to find the arithmetic progression of any given term is given as follows. T sub n equals to A plus bracket n minus 1, close the bracket, multiplied by D. This formula is very, very essential in dealing with any problem concerning AP. Let's illustrate this concept with the following examples. Example 1 says, find the 10th term of the AP below. 5, 8, 11, ... Solution to the problem. To find the 10th term of the progression, 5, 8, 11, etc. Let's identify our terms. Our A is equals to 5. Our D, solving it out with two immediate numbers, we have A minus 5, which is equals to 3. Now, solving with the formula, which is T equals to A plus n minus 1 bracket D. The third term we are looking for is described there as 10, which is the n. A, which is the first term, is equals to 5. The common difference, which is D, is equals to 3. Hence, we can substitute into the formula, which can be seen as T sub n equals to 5 plus 10 minus 1 when we put the value of n as 10. Now multiply by the difference, which is 3. When we open the bracket, 10 minus 1 will have 9. So when we simplify, we have 5 plus 9 multiplied by 3, which is 5 plus 27, which is 32. We can conclude that the 10th term of the expression we are given is 32. Let's also look at example 2. The question says the 6th term of an AP is 35 and the 13th term is 77. Find the 20th term of the progression. Solution. T sub n is equals to A plus bracket n minus 1 bracket D. When we solve from this formula, from the sentence, we are given the value of the 6th term and the value of the 13th term. We will use these values to form two equations, which is as follows. The 6th term, which is T sub 6, is equals to A plus bracket 6 minus 1 multiplied by D equals to 35. When we open the bracket, we have A plus 5D equals to 35. We can regard this as equation 1. Also, using 13th position, we have A plus 13 minus 1 multiplied by D equals to 77. Opening the bracket, we have A plus 12D equals to 77. This could be also regarded as equation 2. Now, solving equation 1 and equation 2 simultaneously. A plus 5D equals to 35. A plus 12D equals to 77. That's equation 2. We can say equation 2 minus equation 1, since the coefficient of A in the both equation is the same. Now, when we say A minus A, we have 0. 12D minus 5D will give us 7D. 77 minus 35 will give us 42. Now, when we make D the subject of the formula, we divide both sides by 7, which is the coefficient of D. And that will give us 42 divided by 7, we have 6. Therefore, the value of D is equals to 6. Hence, we put the value of D in equation 1 to obtain the value of A. When we do that, we have solving from A plus 5D equals to 35. We have A plus 5 multiplied by 6. When we add the value of D, it equals to 35. If we open the bracket, we have A plus 30 equals to 35. Solving for A, we have A equals to 35 minus 30. You can see that the value of A is equals to 5. Hence, we can now go and solve for the 20th term we are looking for. Solving from the formula we know, having the value of A as 5 and the value of D as 6. We can substitute in the formula of T sub n equals to A plus bracket n minus 1 bracket D. Putting the values, we have 5 plus 20 minus 1, all in bracket multiplied by 6. When we open the bracket, when we simplify what is in the bracket, 20 minus 1, we have 19. 19 multiplied by 6, we have 114. And when we add the value of 5, we have 119. We can conclude that the 20th term we are looking for is equals to 119. Now let's look at question number 3. The question says the first and the last term of an AP are 11 and the minus 22 respectively. If the common difference is minus 3, how many terms are there? Let's also look at the solution. From the problem, the first term is equals to 11 and the last term is equals to minus 22. The common difference was given as minus 3. Let us denote the value of L, which is the last term, as minus 22. Now, solving from the formula, T sub n equals to A plus bracket n minus 1 bracket D. We are looking for n. We already know the last, which is the 11th term, which is the minus 22. So we'll use it and substitute in the formula with the values of what we have. Then we solve for what we don't have, which is n, and that is what we are looking for. When you do that, we have 11 plus n minus 1 all in brackets multiplied by minus 3 all in bracket. When you open this bracket, we have n multiplied by minus 3, we have minus 3n, and minus 1 multiplied by minus 3, we have plus 3, which is equals to minus 22. Now collecting like terms, we have 11 plus 3 plus 22 equals to 3n. Because we are looking for n, when we carry the minus 3n over to the right hand side, the negative changes to positive. That is the reason why we have 3n on the right hand side. Now when we simplify the left hand side, we have 11 plus 3 plus 22, that is 36. Now can see it, 36 equals to 3n. We divide both sides by the coefficient of n we are looking for. When you do that, you have n equals to 36 divided by 3, which is equals to 12. Hence, there are 12 terms in the expression. I believe with these few examples, you are able to really appreciate this concept, arithmetic progression. One thing in solving problems that concerns arithmetic progression is your ability to remember the formula as well as know the parameters. Whenever you are given any problem that is on arithmetic progression, try as very much to remember the formula and know the parameters. Not just cramming the formula, but you must know the parameters for you to be able to tackle the problems. The formula T sub n equals to A plus bracket n minus 1 multiplied by D is very, very essential. Know the value of A, know the value of n and D in any problem you are given. Now, I will be stopping here for a while. In our next class, we will look at series, which is sum. But for meanwhile, I will want you to look at these examples. The first one says the fifth term of an arithmetic progression, AP, is 9, and the eighth term is 27. Find the 31st term. The second question says the first term of an AP is minus 8. The ratio of the 7th term to the 9th term is 5:8. Calculate the common difference of the progression. I believe by the end of you solving these two assignments, you will be able to testify how well you appreciate this topic. Try more problems on your own